G'day and welcome to another one of my videos. Today we're going to have a look at finding the perimeter of some shapes that actually have some part circles in them called arcs. They get a little bit more complicated and there's a little bit more working out, but if we're careful and use the technique that I've shown you in my previous videos by working our way around so that we don't miss any sides, it will make it a lot easier for you. So let's just do a quick review of my definition of perimeter. Remember, I don't like the definition of going around the outside. I prefer to say that it's the total length of the boundaries there. So that way, start at a vertex, work our way around and add them up. And that way, if there's a missing side, we can pick up an error and then we can go and work out that missing side before we go on. So, what if some of the sides are missing? Well, again, we find that missing side or those missing sides first. So let's get into an example and see what we need to do. So here we've got a quadrant of a circle. We know it's a quadrant, so we've got a right angle in there, meaning it's a quarter of a circle, so that's 90 degrees. And we want to find the perimeter of this circle, and again, it's telling us to round it off to 1 decimal place. So, find the missing sides first. Well, there's an easy one there. Remembering that it's a quadrant, so we've got part of a circle here. So this is the radius of the complete circle. So if that's 3 centimeters, then this must be the same as well, even though there's not a marking there to say that it is. So we can put that missing side in there first. So what we've got is 2 sides, but we still have a missing side there as well. So what I'm going to do is I'm going to call that L because of the length of the arc there. So we can put a different letter there if you prefer, and we're going to find that particular length before we can find the perimeter of our quadrant there. So, twinkle, twinkle, little star, circumference equals 2 pi r. So we write that formula down there. But we're not actually finding the circumference of a full circle. We're only finding it for this part of the circle here, our length L. So what I'm going to do is we're going to replace that C with an L. Now remember, this is quarter of a circle. So I'm finding quarter of the circumference. So that's where my quarter has come from. And my 2 times pi times the radius. And then again, we just do that on our calculator. A quarter times 2 times pi times 3. And that tells us just what that length is. So we get our 4.7123, and that you get a really long decimal, and it continues on forever. So what I'm now going to do is I'm going to just put that on my diagram so it makes it easier. So when I'm finding perimeter, remember I like to start at a vertex and work my way around. So we're going to start at 3, and then our extra 3, and then don't forget this boundary here, which is that 4.7. So 3 plus our 4.7, etc. I've got that written down there. We get our 10.7123. Remember, look back up at our question. It wants us to round it off correct to 1 decimal place. So let's round that off. 1 decimal point. Okay, check the next digit. It's small, so that stays as approximately 10.7 centimeters. So just make sure that when you think you've finished part of the question, that you reread it and make sure that you've got to do, or what you have to do to answer the particular question. So perimeter, we want the total length of the boundaries, not just the length of that part there. Alright, so let's look at another example. So this time we've got a semicircle here. We have to be careful because I'm telling you this whole length across here is 8 meters. And we do have a missing side. So again, let's find those missing sides first. And I'm going to call it L. Okay, it doesn't matter again what we call that. I'm going to call it L. And twinkle, twinkle, little star, circumference equals 2 pi r, because I am using part of the circumference of a circle, so I need to remember that formula. But if you remember, this is not a full circle. Okay, this is a semicircle, so this is half a circle. So to find that length, then I'm going to be half of the circumference. So 2 times pi times the radius. But be careful, it's the radius. This 8 is not the radius. Okay, this is the diameter. So we need to make sure that we halve that to give us the radius. So from the center to the circumference is 4, regardless of which way we go. And so our radius of the circle is 4 meters. So make sure that I'm using the radius in there. Don't put in the 8, which is a common mistake that some people make. So let's work that out on our calculator. And then it says we want to find the perimeter. So let's put our missing side back into our diagram. And just so we don't get confused, I know with a previous video I left those in there. I'm going to take those out so I don't add those as well. Alright, so let's find our perimeter. 8 meters plus our 12.56. There's no other sides in there, our 8 and our 12.56. And we add those together. And then it says back up here, let's round it off to 2 decimal places. Decimal point, 1, 2. Check the next digit. It's a large digit, a 6. So that means this 6 in front is actually closer to a 7. And so we get the perimeter of this semicircle is approximately 20.57 meters. Now if I've gone a little bit quick for you, remember you can pause it, rewind it and so on, so it makes it a little bit easier. Okay, so we've done a quarter of a circle and half a circle, so a quadrant and a semicircle. Let's have a look if it's more of a little bit more unusual of a sector. So let's have a look at one here. I know this does end up being fairly simple if you can look at it quickly and recognize that the degrees in a full circle is 360 and 120 out of 360 is actually a third. But let's ignore that at this point in time, and I'll show you what we need to do regardless of what this angle is in here. So again, find the missing sides first. Now remember, this is part of a circle, so if that's our center, there's a radius. This is also a radius. So we've got 2 radii. They are meant to be the same, so I can put in that that's 5 meters straight away. What we don't have is this missing side up here. So I'll call that again L. So we're finding the length of that arc there, which is part of the circumference. So recognizing that's part of the circumference, so twinkle, twinkle, little star, circumference equals 2 pi r. So let's write our formula down. But we're not finding a full circumference, it's just finding that part L. So what fraction is it? Well, I just take that angle and I put it over 360 degrees. I don't need to simplify it, and sometimes they won't simplify, but I just take that angle and put it over 360 degrees because that's what part of a full circle that will be. So 120 over 360 times 2 times pi times my radius, and yes, 5 is my radius this time. And again, we just do that on our calculator. In our calculator, there is no reason to press the degrees button. Okay, so just 120 over 360. And we find that the length of this arc here is approximately 10.47, etc. So let's put in our missing side there. And now that we have all the missing sides, again, we're going to find our perimeter by starting at a vertex, and we're going to work our way around the figure so that we don't miss any of the sides. So don't stop there because the question says find the perimeter. So let's do that. 5 plus 5 plus 10.47. We get our 20.47. So I haven't rounded anything off until the end. And let's do to 1 decimal place, so 20.4. The next digit is a large digit, a 7, so that 4 is actually closer to a 5. So we get approximately 20.5 meters. So I hope you found these videos useful, especially this one here. So what you now need to do is to practice, and practice some more and practice again. So I've shown you the basics. You will get some more complicated shapes in there, but make sure you just take your time, find the missing sides first, and then total the boundaries, and that will give you the perimeter. So thanks for watching.